Imagine a future where Earth is no longer livable, not destroyed in a single catastrophe, but slowly rendered hostile. Oceans rise, heat becomes permanent, agriculture collapses, and the backup plan fails too. Mars never terraforms, radiation never stops, gravity never forgives, and there is no second Earth waiting. So the question changes. Not where do we go, but can humanity survive without ever landing? In the movie WALL-E, humanity escapes Earth aboard a giant luxury ark, the Axiom, an automated, self-sustaining, and comfortable floating world. It looks like fantasy, but here's the uncomfortable truth. Nothing about it breaks the laws of physics. The challenge is not possibility, the challenge is scale. Let's start with a hard limit. You cannot save everyone. For long-term survival, an ark needs enough people to preserve genetic diversity, culture, and resilience. Below roughly 10,000 individuals, populations collapse over generations. A realistic ark would likely carry 50,000 to 200,000 humans. Even then, survival would depend on AI, managing reproduction, health, and genetics, quietly correcting nature so civilization doesn't unravel. This isn't a ship. It would be a rotating artificial world. To simulate Earth-like gravity safely, the ark must spin. That means radius 2 to 4 kilometers, length 10 to 30 kilometers. Inside there would be forests, fields, rivers, cities, entire weather systems. Because if the ecosystem collapses, there is no rescue. Do we even have the resources to build something like this? Surprisingly, yes. Earth contains more than enough iron, aluminum, silicon, and carbon to build not just one ark, but many. The real limitation isn't materials, it's gravity and energy. Lifting everything from Earth would be suicidal, which is why a real ark wouldn't be built on Earth at all. It would be built in orbit. The logic is simple. Earth provides people, electronics, and precision parts. Space provides bulk mass. Asteroids for metals. The moon for radiation shielding. The sun for power. Once autonomous mining exists, Earth becomes the seed, not the quarry. How long would construction take? With today's technology, impossible. With near-future AI and robotics, 50 to 100 years per ark. Millions of autonomous machines, self-repairing systems, humans supervising rather than building. The ark wouldn't be constructed, it would be grown. Which brings us to the hardest question. Not can we build one ark, but how many? Intuition says, very few. Earth would run out. That intuition is wrong. Earth is not resource poor. It is coordination poor. Without space mining, launch limits restrict us to a handful, maybe a few dozen arks at most. With a mature space industry, autonomous mining, orbital manufacturing, and AI-directed logistics, over a century, humanity could plausibly build dozens, possibly hundreds of arks. Not enough to save billions, but not just one lifeboat either. How long could humans survive on an ark? If designed correctly, indefinitely. Not decades, not centuries, thousands of years. The limiting factor wouldn't be technology. It would be culture. Every generation born aboard the ark moves further from Earth, until Earth becomes a myth. A blue story told to children who have never felt wind that wasn't engineered. At that point, a final question remains. Are we saving humanity or preserving a biological pattern inside a machine? The ark would protect our bodies. AI would protect our systems. But whether it protects our humanity depends on something harder to engineer. Meaning, choice, responsibility. Maybe the real ark isn't the ship. Maybe it's our willingness to redefine what it means to be human when Earth is no longer home. If Earth dies and Mars fails, survival won't come from escape. It will come from adaptation. And from the intelligence we create, not just to save us from the universe, but to help us survive ourselves.